Timeless Concepts from Physics Helpline. This is a video tutorial series through which we will sharpen our problem solving skill. First, we will analyze the problem on hand to find the related concepts. Then using these, we will develop a method which will produce the solution. This will help the students aspiring to get into IIT to understand the much needed advanced theories and applications in physics. In this video tutorial, we will discuss a multiple choice question with one or more correct options on angular momentum and center of mass. The question is as follows. A uniform rod AB of length 6 meters and mass 8 kg lies on a smooth horizontal surface. Two particles of masses 1 kg and 2 kg are moving on the same surface in opposite directions and perpendicular to the rod with speeds 20 meters per second and 10 meters per second respectively as shown in the figure. They collide with the rod at distances 1 meter and 2 meters from the ends A and B of the rod respectively and stick to it after collision. Then after the collision, the options are A. The velocity of center of mass of the system is 0. B. The angular speed of the system is 2 radians per second. C. The moment of inertia of the system about the axis passing through the midpoint of the rod and perpendicular to its length is 30 kg meter square. D. The total energy of the system is 60 joules. Before proceeding to solve the problem, let us recall the related concepts. Linear momentum of a system is conserved when the net external force acting on it is 0. Similarly, angular momentum of a system is conserved when the net external torque acting on it is 0. A freely rotating system always rotates about its center of mass. In such situations, it is necessary to determine the moment of inertia about an axis passing through the center of mass of the system. In case of pure rotation, a system does not possess translatory motion. Hence, the total energy associated with its motion is its rotational kinetic energy. When three particles of masses m1, m2 and m3 are located at positions x1, x2 and x3 with respect to an arbitrarily fixed origin, then the position of the center of mass of the system with respect to that origin is given by x is equal to m1x1 plus m2x2 plus m3x3 divided by m1 plus m2 plus m3. Now we are in a position to solve the problem in the question using these concepts. Let us first determine the position of center of mass of the system. Let us choose end A of the rod as the origin. Now mass of the rod is m1 is equal to 8 kg. The position of its center of mass is its midpoint O. Therefore, x1 is equal to 3 meters. Mass of particle 1 is m2 is equal to 1 kg. Its position is x2 is equal to 1 meter. And mass of particle 2 is m3 is equal to 2 kg. Its position is x3 is equal to 4 meters. Therefore, position of center of mass of the system is x is equal to m1x1 plus m2x2 plus m3x3 divided by m1 plus m2 plus m3. Putting the values and simplifying, we get x is equal to 3 meters. We observe that AO is equal to 3 meters. Therefore, the center of mass is located at O. Therefore, when the system rotates freely, it will rotate about an axis passing through O. Hence, we will do our calculations with reference to this axis. We observe that no external force acts on the system. Therefore, linear momentum of the system remains constant. Now, initially, linear momentum of the rod is equal to 0 since it is initially at rest. Particle 1 is moving parallel to positive y direction, which is indicated by J cap in the figure. Therefore, momentum of particle 1 is equal to plus 20 kg meter per second. Particle 2 is moving in the opposite direction. Therefore, momentum of particle 2 is equal to minus 20 kg meter per second. This implies total initial momentum is equal to 0. Since momentum is conserved, the total final momentum is also equal to 0. This implies that the velocity of center of mass is equal to 0. Therefore, option A is correct. Now, we calculate the moment of inertia of the system about the axis xy passing through O and perpendicular to AB. Moment of inertia of the rod about the central axis is equal to 1 by 12 ml square, which is equal to 24 kg meter square. Moment of inertia of particle 1 is equal to mass into OP square, which is equal to 4 kg meter square. And moment of inertia of particle 2 is equal to mass into OQ square, which is equal to 2 kg meter square. Therefore, moment of inertia of the system about xy is I is equal to 24 plus 4 plus 2, which is equal to 30 kg meter square. Therefore, option C is correct. Angular momentum of the system is conserved as no external torque is acting on it. Initially, there is no rotation. Also, we observe that angular momentum of both the particles about xy due to translation are clockwise. Therefore, total angular momentum is equal to sum of their angular momenta. Here we will use the relation angular momentum is equal to mass into velocity into distance from axis. Therefore, total initial angular momentum is equal to 1 into 20 into 2 plus 2 into 10 into 1, which is equal to 60 kg meter square per second. Finally, there is no translatory motion. Therefore, angular momentum of the system is due to its rotation. Let its angular velocity is equal to omega. Then, final angular momentum is equal to I omega, which is equal to 30 omega. Equating the two, we get 30 omega is equal to 60 which gives omega is equal to 2 radians per second. Therefore, option B is correct. Since there is no translation after the collision, the total energy of the system is equal to its rotational kinetic energy, which is equal to half I omega square, which is equal to half into 30 into 2 square, which is equal to 60 joules. Therefore, option D is correct. Hence, all the options given in the question are correct, which is the answer to the question.